So let's have a go at these past exam questions. The first thing we need to do is we need to find the structure of an alpha particle. So you should know that an alpha particle is 2 protons and 2 neutrons, so 4 particles in total. This is a really easy question, even if you don't understand what all this is going on about. 2 charged particles and 2 neutral particles make 4 particles. 2 plus 4 is 6, so it can't be this one. 4 plus 2 is 6, so it can't be this one. 4 plus 4 is 8, so it can't be this one. You should know that the 2 charged particles are the positive protons and the 2 neutral particles are the neutral neutrons, so it is this one. Which statement about beta radiation is true? It is the fastest moving type of radiation. That's false. It is the type of radiation with a negative charge. That is true because it is a high energy electron. It is the type of radiation with the greatest mass. That would be false because it's alpha. It is the type of radiation with the greatest range of air. That would be false because it is gamma. Which statement about gamma is true? So it has a very long range in air all the way down the bottom. It's literally what I've just said. It's this one. These two might not make any sense to you right now because it's going to be covered in lessons in a few lessons time. It is a low frequency electromagnetic wave. It's also false because it's a high frequency electromagnetic wave. Next question, we have a diagram of helium here. Which part of the atom represents an electron? You should know this at the back of your hand. It's L. These electrons orbit in the shells around the nucleus. Which part of the atom, KLM, LM or N, represents an alpha particle? Remember, an alpha particle is a nucleus of a helium atom, so it's this part in the middle, which is M. A radioactive source emits alpha particles. Why? What might this source be used for? So use your head here. To monitor the thickness of aluminium foil. Why is it not going to do that? Well, because alpha can't get through aluminium foil, so it's never going to be able to measure the thickness of it. To use as a smoke detector, that is the correct answer, but I'll come back to that in a second. This one, to inject into a person as a medical tracer. Why would you never want to inject anyone with alpha? Well, because it's highly ionizing, which means it would mutate DNA and could cause cancer. So actually, alpha particles, a source of alpha radiation is what you put in smoke detectors in every home. Right, the 6 marker. If you get given this, it's kind of a gift. These are really good 6 markers to get in an exam because there's loads you can write about. Right, the one thing that is a trouble with these questions is because this one says hazard or danger, and that's quite a hard word to deal with, and I'll explain why in a second. So what we've got to do is explain how the properties of alpha, beta, and gamma radiation affect the level of the hazard at different distances. Now, hazard is the issue here. A shark is dangerous to me, but is it dangerous to me right now? No, because I'm not in the sea. So each of these is going to be dangerous to you, or the most dangerous in different situations. What we need to think about here is, can it reach me? Can it penetrate cells? And how much damage does it do? So the first thing we're going to do is we're going to talk about alpha, beta, and gamma. We're going to try and answer these things to start with. So properties. Alpha is the least penetrating, it's the most ionizing, has the least range in air. Beta is the second most penetrating, it's the second most ionizing, you could say medium here, or moderate instead of second. And beta has the second longest range in air. Beta is always this intermediate, it's always in the middle between alpha and gamma. Gamma is the most penetrating, and it has the greatest range in air, but it is the least ionizing. You could write all of this down, but only get 2 marks out of the 6. And it's because you have to link this to the hazards that these present at the different distances. So this is what you need to get anywhere between 3 to 6 marks now. So by saying that alpha is the most dangerous at short range, because it's the most ionizing, but it has to be really close to the cells to do any damage. The mid-range beta is the most dangerous because it's more ionizing. It's less ionizing than alpha, but more ionizing than gamma. And if it can reach you, then you're in trouble. And at long range, gamma is the most dangerous, but because it's only low ionizing, but it can get you basically anywhere. And that's what a lot of background radiation is. So to get 6, you would need to include all 3 of these and all 3 of these. So you'd have to link the properties to the hazards they present at different ranges. Again, always look out for that word hazard